Good afternoon. I'm Marty Lane, Business Development Manager at Enterprise Precast Concrete, and I'll be today's moderator. Today's presentation is sponsored by PCI of Illinois and Wisconsin, PCI Midwest, and PCI Mountain States. Their goal is to bring greater awareness of precast concrete to the design and construction community via quality continuing education programs. Before I turn things over to our presenters, let's review a few housekeeping items. You can submit questions through the presentation by typing them in the questions pane on your GoToWebinar control panel, but we won't address them until the end of the webinar. You can download a PDF of the presentation from the handout section on the GoToWebinar control panel. Don't worry if you can't find it, because links to the handout and a recording of the presentation will also be emailed to you after the webinar. Attendees who fully participate in today's live webinar will receive a certificate of attendance for 1 professional development hour or 1 AIA learning unit with HSW credit. To qualify, you must be logged in individually and attend the majority of the live presentation. A link to your certificate will be emailed to you within 10 business days. If you provided your AIA number during registration and you attend the majority of the presentation, Margaret Mills will report your attendance to the AIA on your behalf. If you're watching this webinar in a group setting where only one person is logged into the GoToWebinar, please email Margaret the names and contact information of everyone attending with you. Without that list, she won't be able to issue certificates of attendance. If you need your hours reported to AIA, please be sure to include each attendee's AIA number as well. The course description and learning objectives were listed in the registration process, so we won't take time to read them now. Remember, we will answer questions at the end of the presentation. Finally, let me introduce our presenters. James Evrard is an architect and planner with CRB's Life Sciences Group in Kansas City, Missouri. He is a graduate of Kansas State University and the University of Missouri, Kansas City. James brings extensive experience in both design and construction, having worked across a wide range of project types, including custom residential, nonprofit, civic, commercial, justice, healthcare, and K-12 and higher educational facilities. This diverse background provides him with unique perspective on how buildings are designed, constructed, and ultimately occupied. He is passionate about design at every scale, from initial planning and concept development through detailing and construction, and believes that thoughtful design is essential to creating meaningful, high-performing environments. James is highly engaged with the American Institute of Architects, having served on the board of directors for the AIA Kansas City chapter, along with its committees. He is currently the co-chair of the AIA KC Advocacy Committee. In addition, James co-created AIA Kansas City's Legends and Leaders series, documenting the chapter's legacy by connecting emerging professionals with prominent members of the Kansas City's architectural history. Dirk McClure is the Director of Business Development for Enterprise Precast Concrete's Kansas City location, where he oversees the 5-state market territory of Kansas, Missouri, Illinois, Northern Oklahoma, and Northern Arkansas. He has a Bachelor of Interior Architecture from Kansas State University College of Architecture, Planning and Design. Prior to joining the precast industry, Dirk spent 8 years practicing sports architecture. His diverse AEC industry background gives him unique overall knowledge of the built environment. Dirk spent 10 years serving on PCI's Sustainability Council and is currently on the board of directors for the Design Build Institute of America's Mid-America chapter. Dirk has authored articles published in the Construction Specifier, the International Institute of Building Enclosures, Consultants Interface, and PCI's Ascent magazines. Before I turn this over to James and Dirk, I'm going to announce again that in order to receive a certificate of attendance for this program, you need to be logged into the GoToWebinar system and must attend the majority of the presentation. Certificates of attendance will be emailed to you within 10 business days. If you do not see your certificate within 2 weeks, please reach out to Margaret Mills. With that said, James and Dirk, you've got control of the screen now. Let's get started.
Thank you, Marty. Well, we are pleased to be here continuing our Precast Perspectives series. Today, we're going to be walking through 5 case studies of schools that were designed with precast. We're going to talk about some of the trends that are happening with school design and some of the ways that you can really push the limits with aesthetics. So good morning or good afternoon, whenever you happen to be listening. And thank you for joining us. We do have a lot of content to get through in a short amount of time, but I will tell you that James is a sports car guy, and my midlife crisis outlet is a Harley Davidson. So we're both used to moving pretty fast. I think we'll be okay. Buckle up. Here we go. So precast, the primary attributes and benefits can be divided into three categories: versatility, efficiency, and resiliency. I'm not going to spend time breaking these down, but I did want to throw this up on the screen as a point of reference, because as we are walking through the case studies, you will see that many of these buildings obviously have attributes and benefits that fall into one or more of these categories. We encourage you to really lean in from a precaster's perspective. We encourage you to really lean into your precast community. Most precasters are going to have a staff member on board that is available to assist you early on with projects, regardless of what part of the country that you live in. And they can help you with budgeting. They can help you with samples. They can help you with specification assistance, making sure that those written specifications, align with the design drawings. And they can help you with panel layout, roof connections, making sure that that design is as efficient as it could be. And I'll just give a quick example of one time that played out. This was a project in Lenexa, Kansas. It was originally envisioned as a masonry project. They were having some issues getting their schedule and their budget to calc out. So the precaster was brought on board to explore the idea of setting thin brick precast into large precast panels and then using exposed precast down at the base. So they started by breaking it up with a series of columns and spandrels, which was hopeful, but it didn't really unlock the full efficiency. In delving in a little deeper with the architect, they found out that there was some flexibility in the window size and the window locations. So they were actually able to, as you see in the bottom left corner, the production photo, they were able to do one large 3-story window, or one large 3-story panel with 3 punched openings. And they were able to basically take that form and repeat it. So you can see there's a lot going on here, a lot of bump outs, some transitions and different things. But from a precaster standpoint, this was a very budget and schedule driven job. And that repetition is what made it such an economical project. And that was the precaster working with the architect on the front end for the betterment of the project. Your precaster can help you with determining the appropriate certification designation for the project. And just to give a little bit of helicopter perspective on certification designations, there are 4 categories in the current certification system that started 5 years ago in 2021. Going from the right, AA is the highest level of complexity. So these are the tightest tolerances. These are your performing arts centers. These are your cathedrals. These are the projects that need to be so near perfect. You're going to have a client with very high expectations that you want to, look at that highest level of certification. When you get to AB, the tolerance gets to the more conventional 117 manual, and you can do curves. You can cast not just thin brick, but you can also cast natural stones, granites, limestone into the product. You can introduce specialty textures like graphic concrete and things like that. When you get to the AC category, this is to editorialize a little bit. I would consider this probably the most common certification level. It's what the old A1 certification used to be. These plant panels tend to be flat in nature, but you can do multiple finishes on an AC panel. You can do thin brick. You can do form liners. A lot of school construction falls into the AC category. The examples that I'm going to give today, one of them is an AC project. The other four were produced in production facilities that are currently AA certified. Then the last category is AD. These are gray panels that they don't have to be painted, but in most cases they are going to be painted. These are going to be your big box stores. These are going to be your warehouses. Although interestingly enough, because it loosens up to the old manual 116 standards, we're finding even on warehouses and big box stores, a lot of people would like to jump up to the AC category. So they specify AC. So an AA certified producer can hop down to AC, but the idea is an AC certified can't bid on an AA project. So if you're doing AC and you're used to getting 5 to 6 precast bids, if you specify AA, you might just get 2 or 3 bids, but they would be precasters that are specified in that category or certified in that category. With schedule, once an architect or a contractor has done a lot of precast jobs, they start to get really savvy in their precast procurement. What you see at the top here represents a more traditional design bid build method where everybody gets on board at the same time. Then the shop drawing process starts, the sampling process goes on, the production process, then getting the project to the job site. The only issue with that is it takes longer to get long lead items like precast to the job site. Now, once they get to the job site, it's the fastest construction method possible. They're putting up, 10 to 14 panels a day, sometimes more. So about 120 lineal feet of construction. But what a lot of people do is they will use the methodology down in the bottom. They will negotiate with a preferred precaster who budgets the job in a design build scenario. Or if it's, say, for instance, a school job where that needs to go out to bid, they will issue an early core and shell package. Once that shell is locked down, get the key contractors on board, like the precaster becomes a design assist partner. They open up their detail library. They help with the efficiencies, with the detailing. And while the architect is going through CDs, that process gets started earlier and they get into their building earlier. I'm going to be handing things off to James here momentarily, but the first case study we're going to talk about, the one we're going to do the deepest dive on, West Park Elementary, that used the methodology that you see at the bottom here with the expressed schedule. For finishes, you can do sandblast, which is the most common finish in the industry. It's an abrasive blast that mars the aggregates. There's varying degrees of sandblast, light, medium, or heavy. Each is going to yield a little bit different look. There is exposed aggregate, traditionally referred to in the industry as a retarder finish. That's where a chemical retarder is painted on the bottom of the bed. It keeps just the surface fraction of an inch from curing. So when the panel is extracted, that surface concrete is washed off and it exposes the rock. Then there's also an acid etch finish, which is the least evasive finish. That's a liquid-based application that just takes the blotchiness of the form finish off and gives it a nice, clean, almost sugar cube look. And then there's other specialty finishes like various polishes, hone finished, distressed finishes, things like that. What we want to do at this time is transition into our case studies, and I'm going to hand things over to James. I will tell you, I've had the pleasure of working with James for about 15 years now on a variety of projects. And he is a person that is really pushing the limits of what you can do with precast in a good way from an aesthetic standpoint. So when we work with him, we always have discussions about kind of how that panelization looks like. And not just that, but even if it's a thin brick job, how the brick coursing is going to work out. He really delves into the details in a way that's to the betterment of the project. So he's a great precast partner. Glad to have him here today. James, take us away.
Well, thanks, Dirk. Yeah, it's great. I mean, throughout our career together of collaborating on buildings, especially coming up with innovative designs, and yourself as a precaster to lend some realistic measures to them with being able to be produced and constructed to meet our clients' needs. It's been very fortunate. So as Dirk said, we're going to be getting into West Park Elementary, but wanted to first give a shout out. I know we're talking about some school case studies, but just shout out to CRB. We are a custom build to suit company with architects, engineers, consultants, constructors, where we work on a lot of different scales for life sciences, food and beverage, clean rooms, labs, a number of different projects that are soup to nuts, custom, bespoke projects that utilize a lot of different construction methods for our clients to make these projects a success. And some of those, involve precast with a very fast, fun, detail-oriented facade that can go up and encapsulate these production processes for our clients in a very clean and aesthetic manner that is straightforward to build and long-lasting. So very happy with being able to utilize precast and partners like Enterprise on these projects. So getting into the main project that we're talking about is a project that I did while at HTK Architects. So shout out to HTK for the wonderful work they do for the education space. And I was fortunate to be the main designer, project architect, project manager on this job. This was a interesting project. West Park was part of the 2018 bond through KCK Schools, USD 500. And J.E. Dunn was the construction manager at risk on the job. And one of the main components of the whole bond was the replacement and merger of several educational facilities through the district. One of them was West Park, which was a brand new build on an existing site. It was about 72,000 square feet of plan overall, featured, we'll get to a plan in a second, featured a number of site constraints and challenges with building on top of an existing middle school that was demolished, merged two elementary schools that were demolished, and those populations came here. And this project was also done right before COVID. Design started around fall of 2018. Construction was 2019 to about July of 2020. So it faced a number of fun schedule hurdles and design challenges that we were able to bring effective partners on, such as Enterprise with our CM, J.E. Dunn, to make this project a success. And the one thing I want to stress before getting to the plan is that looking at how traditional school design has started throughout with, double loaded corridors and typical classroom arrangements, this project sought to be very efficient, organized, and straightforward, but also celebrate the contents within the plan and give differentiation to the different areas of the school. So this is the overall plan. So the building itself, with the site challenges of utilizing the existing flat area from the demolished middle school, was a north-south oriented building, very linear, very horizontal for its site. So the classrooms were arranged in a way where there was the main admin and media center space at the front, which is the right side of the lower drawing. And as you progress through the school, you're progressing in a linear fashion through a double-loaded corridor where classrooms are organized in nodes with central entry areas to help break apart and organize grades. But another thing that was done with being a very horizontal school, you'll see through the elevation work that a number of vertical elements were incorporated, that precast was a necessary material to utilize with this form, where we were stacking classrooms for efficiency, but the differentiation of the aesthetic helped with how precast, you can do different bed treatments, different aesthetic treatments to help organize and provide a nice design language. And through that, there's a central great hall that is a 2.5 story space that stacks a vertical element of a clear story to give some scale and grandeur to the entry. And then the main classroom wing itself. And then it transitions into a lower level with the ICC 500 gym storm shelter, and then the electives wing of the flex classroom and art and music room. So a lot of different program, and through the necessary areas of precast, we were able to differentiate these. And there is a lot of fun with doing a school and being able to use precast as an aesthetic. And I know this is one of Dirk's favorite panels because being a school, we look to use thin bricks such as indicots. So we had a red brick blend that we were able to utilize that evoked, traditional school design with the red brick building, but turned it on its head with some sprinkling in of some dark indicot bricks with the red shades, and then be able to utilize a repetitive module that you'll see is very playful on the exterior, but use it in different ways that highlight different precast finishes. Right here is where we did in-panel reveals that brought the matrix color out to the front of the panel. So the project itself had two matrix colors, this dark gray matrix, and then in the next slide, this warm matrix with the same type of panel reveals. Instead of bringing it to the surface, we used that panel retarder to give it a light etching to push it back and give it a different finish on the form. And the face finish itself was a light sandblast. So creating different textures within the same panel, using the module for different playful aesthetics, really helped organize the different volumes of the school to give differentiation. So you're going to the front door, you're going to the gym. This image on the right side of the screen shows the stacking of the classrooms, but we have a nice, good, solid medium band that breaks up the elevation through the red brick blend, utilizing elements of the high precision of precast, where we have a single brick black line that helps organize the sill and header of the window forms within the precast. And then one of my favorite elements is where we have offices, restrooms, utility spaces. Those are organized by vertical elements of acid etch precast with also another form liner reveal that help break up the horizontal form that I originally talked about. So you can see here with that same interplay of modules and forms, just rotated, mirrored, just organized across the facade. So there's a similar language, but that playful language is then further differentiated by the precast type. So two matrices, two very different aesthetics that are still unified in their construction. And then we had some elements such as these entry pieces that were accented by black indicot brick that helped break away and kind of subtly announce entrances without trying to be too domineering. This is one of my favorite finishes that I've used throughout my career. This is a black matrix precast that's the same that you saw in earlier slides, but it's slightly acid etched to give a nice lightened finish to the overall form. So it kind of dances in the sunlight as it is showing here in the picture. And it just kind of promotes like a softness, of really touchability, especially for a school where kids like to get their hands on everything. But it just helped provide vertical forms and organization. So this also accented a stair that was within the form with the two-story glazing. So it really helped promote individuality through these elements, but also not taking away from the organization of the classroom stacks. And then on the interior, we brought some of the form work into it, which for the ICC 500 gym was very essential. So that playful form helped organize interior spaces. You see the lunchroom on the left side of the screen, which was a grade A finish with a very smooth precast interior face that was used to mount acoustic panels to help break up the overall sound transmission in the room, but also, still show that nice solid construction that what precast is known for. And then another fun thing, which was the ICC 500 gym. And this is that playful sandblast form on the exterior. And there was a lot of really fun things with using modules here. And as an architect, being able to collaborate with a precaster and J.E. Dunn as a builder, where working with our modules, which we have 12-foot T's, 12-foot panels. So align all the things, and, you know, it just helps with the repetition of the acoustic panels and the playfulness of the color in the ceiling, the ductwork, where precast as a modular aesthetic really helps organize your creative thoughts with how you shape interior spaces with, you know, rooms that are sometimes uninviting, being a storm shelter, but here it's being able to use it as a positive. And, you know, also getting into some of the things with further into modules is how looking at different types of modularity through the thin brick process that was shown on the outside. So being able to understand how these sizes stack and scale and line up with the precast panels is really essential. And Dirk definitely can lend that advice to that.
Yeah, so this is obviously the 4 most common sizes of thin bricks: modular, Norman, closure, and utility, and they have corresponding similarities in terms of either height or length. Precasters and thin brick companies will do random blends, which helps sell that look of it being a full brick project. They come with certain recommended tolerances for PCI, with a recommended compression strength for PCI, because they're going to have the weight of that concrete on top of them. And a thin brick that has met PCI's recommended standards will have been through 300 freeze thaw test cycle, basically simulating 300 summer and winter seasons. You can see here on the top right photo, they will actually, on the exposed corners of the building, will do a corner brick, which will help to sell that illusion that it is a full brick. And it really has gotten to a point, the technology, where it takes an educated eye to know the difference. You can see the picture on the bottom there. They typically provide grooves in that brick that bonds directly with the precast. And in that rubber liner, there's a little curved lip there that emulates a tuck point. So that reinforcing is put down, the concrete is poured on top, and it shows through and essentially becomes your mortar. You know, a couple of other things that I really like about West Park Elementary, in James's design, here you're looking at 2 different sides of the same wall. And he took that interior corridor and put the specialty finish on that. So it was a great tie-in from the exterior to the interior, that primary corridor. And then, of course, they painted the other side of that wall in that cafeteria. You know, it was also a great story in terms of sustainability. You know, in addition to the typical contributions of precast, like regional materials, recycled content, thermal mass benefits, the resiliency of a high wind structure. I mean, this elementary school utilized an existing footprint for the previous middle school, so it really minimized the site disturbance and the impact to, you know, the large amount of green space that the site features. So that was West Park. Another project that we did was Crestview. The interesting story here, the gymnasium on this project was very front and center. When you pull into the school, it is the first thing you see. It's very visually prominent. So they wanted to do something that had some wow factor. And you can see that was primarily achieved through this zigzag pattern that was achieved with a combination of exposed aggregate retarder finish and sandblast finish. So shout out to DLR Group, who designed this, and McCowan Gordon Construction, who was the CM on this project. Another, you know, interesting aspect of this school, it's North Kansas City School District is the 2nd largest school district in Missouri. And this particular elementary school, it is the most racially and ethnically diverse elementary school in the state. There's over 100 nationalities represented in the student body, and it was designed to really embrace that community's culturally rich neighborhood by integrating multiculturalism into the physical environment. So, the architect, talked about how the whole building shape mimicked the creek bed that runs behind it. The center of the building is called the canyon, the melting of all the cultures. So they played with the concept of a canyon on the exterior of the precast. And you can see that carried through with the zigzags on that facade of the ICC 500 shelter. The panels were 8 feet wide by 32 feet tall. And then there were 8-foot double T's, which corresponded with the wall height. This was actually done. It was one of the first projects produced out of Enterprise's new facility in Kansas City, which is an AC certified facility. That is what we most commonly see for school specifications. The remainder of these projects were done out of a facility that is currently certified as AA. So you can do a really nice looking project with AC. And that was Crestview Elementary. A little side note here, I'm going to share a personal story. This is my daughter, Kalia. She's a junior in college, but almost exactly 2 years ago, she was getting ready for her junior prom. And they had a significant weather event that day. There were tornado watches all day. And as the day went on, it looked like it was going to turn into a tornado warning. And there was a big question all day long, can we still go ahead and have their prom? And because of the way things are set up, where they have reservations, they have rentals for outfits and dresses and tuxes and that sort of thing, it wasn't a matter of rescheduling it. They were either having the prom that night or they were not having the prom. And this discussion went on all afternoon long. And my wife was telling me, well, the school has come to a compromise with the students. They decided they can go ahead and have their prom, but instead of having it down the street at the country club they rented, they need to mobilize everything, get the DJ, the decorations, everything to their own school gymnasium and hold the prom there, because it was actually the timing of their prom was the apex of when it looked like this event might happen. And my wife asked me, she said, "Are you okay with this?" And I said, "Are you kidding?" I said, "This is an ICC 500 compliant precast FEMA structure designed to withstand 250-mile-per-hour winds, an E5 tornado, or a Category 5 hurricane." I said, "She is going to be safer in that facility than we're going to be in our house." And at this point, my wife is just looking at me with a glazed look like she temporarily forgot that she was married to a precast nerd and then just got bluntly reminded. And I told her, you know what, we should actually talk to the coordinators, see if they need any more chaperones. We could weather this out with her at her prom. And I was kidding. We did not go show up there and embarrass our daughter. But I did ask her when she got back if she had a good time. And she was like, "Dad, I had the best time. Yeah, precast concrete saved my prom." And she knows a little bit about precast. She and my wife have been out to our Kansas City production facility before, as you can see in the top photo. But this really, precast is more about just saving fun. This is an example of how the resiliency and the durability of these structures are literally protecting life. You don't have to wait for a big event that it happens to coincide with. These structures can serve in that capacity, in an amazing way. So that, that's one of the ways that precast is really transforming the communities that this building method serves. So that's my side story. On to our third case study, and that is the Murphysboro Performing Arts Center. So this was an interesting set of circumstances that got us to the job site. It was replacing an older facility that was built in the 70s. It was built out of CMU, full brick, and it had a wood truss roof. That structure actually buckled under the weight of some roof units that they had, and it experienced a catastrophic failure. The roof caved in, the walls crumbled. Basically, their old performing arts center fell down. And fortunately, that happened when nobody was on site, nobody got hurt, but immediately there was a lot of eyes on this project, and they had three primary goals. They wanted to build something as fast as possible. They wanted to build something as durable as possible. And with the PR and everything else going on, all the eyes they had on this project, they wanted to build something that would really make a lasting impact visually. So that was done with precast concrete wall panels, obviously for the speed and the durability. And for the wow factor, they employed graphic concrete for one of the first times in the United States on a large scale like this. It's a technology that had been done in Europe for over 20 years, but was new to the US. Now it's been done in the US for about 10 years now. Graphic concrete is a technology where you can impart any image or pattern or design onto a precast concrete surface permanently. So you can do letters, you can do designs, you can do like a detailed stippled pattern and do a person's face. The way this is achieved is a design is printed on a membrane paper, whether it's a custom design or a standard design. We see a lot of custom designs, a lot of team logos and things like that. And then the paper's put down in the bottom of the production bed, the precast panel's poured on top. It's extracted out of the production bed, the paper's peeled off, and then they literally just wash that panel. And wherever the print is, it has a mild chemical retarder that actually keeps that surface from curing. So wherever there's print, it actually exposes a finite specialized aggregate. And wherever there's no print, it just leaves the form finish. So you can do a number of designs. The roll comes 10 feet, 6 inches wide, but obviously unlimited length because it's on a roll. And if you get large enough and you get repetitive enough, the pricing comes within striking distance of a complicated thin brick project. So here you can see on Murphysboro where they started out on the drawing table here. They wanted basically a park-like design, and they took it quite literally. It was like images of trees that they put on these patterns. So then we went, of course, to the mock-up phase, did a mock-up. This starts out abstract and then becomes clear when you pull further away from it. But we had discussions about what we were doing with reveals, depth, locations, that sort of thing. That's a really important part of the precast process is doing a mock-up for those reasons right before you go into production. And then this was the finished product. So the gray panels that you see in the back there, that was the precast, that was the Performing Arts Center. So this was a pretty high level difficulty job. There are very few right corners in this building. So this is a kind of project you probably want a precaster that is an AB level or above to be working on. It'll get really interesting when those trees grow up, and they also put in lead lighting, some LED lights in there, with different colors. So they use that seasonally or depending on what event they're having in that structure in the evening. Here you can see, if you look to the right, a close-up of that pattern, and it starts out obviously a bit abstract. And then when you step back, the image, becomes clearer. So that's a kind of a neat attribute of graphic concrete. And it's just another great tool in the toolbox. That was the Murphysboro High School. And there's the inside of the auditorium. You might be able to just make out the joints there on the wall. They put in a little bit of a faux lick and stick stone on one of the interior walls there just to dress it up a little bit. And on the right, you can see kind of that park theme as you walk up to the school. It's a little bit of an experience as you approach it from that direction. And that brings us to the Kansas City Art Institute. So this is a higher education project. This was actually a residence hall that was built for art students on the Kansas City Art Institute campus. Shout out to the designer, Helix Design, the contractor, J.E. Dunn Construction. This was achieved with a white precast that had a combination of acid etch and exposed aggregate finish. You can see on the end cap there those gray panels or the gray portions of the panels. That was the exposed aggregate. Something that they really wanted to employ here. They wanted to do something really playful, and they achieved that with these pops of color. Now that was done with a field applied staining that happened on site, and to allow for that really vibrant color. But one thing I do want to point out, you might be able to see how those windows are recessed. That was actually the precast that was tapered. So that red, yellow, and green stain is going directly, it is directly adhering to the precast. So everything you see in this photo is precast with the exception of the glass and the cast in place stem wall at the very bottom. So this ended up being a really nice project. It was the AIA Kansas City Project of the Year in 2020, which is about the only thing I want to remember about 2020. But it was a really nice project, though. I liked this detail in their grandstand area. They did one of James's tricks. They brought the exterior into the interior, and in this case there were windows there, so you could see it really created a nice connectivity to the exterior in that area. And then in the actual dorm rooms, they left, the structural gray interior white of this insulated sandwich panel exposed. So it kind of just, the dorms themselves kind of have this modern day loft feel, which is perfect for artists.
Very beautiful and playful project. Good use of color, modules, good scale, really great project.
Yeah, they did a great job on that. So that brings us to our final case study, and that is the Tekamah Herman School up in Nebraska. This is a project that actually my regional counterpart, Marty Lane, worked on. He's moderating our discussion today. So what I wanted to do with this one is use it to illustrate kind of how the precast process works, with shop drawings and production and putting those panels into place. So we start out with obviously a set of drawings from the architect, like you see here. And then we will do an estimate, and we start by reviewing the specifications and the documents, and then we'll do a takeoff and we'll panelize that project. If we're lucky enough to work with James, he's already thought about that. Sometimes, we're the first ones to think about it. Either way, it works out. So what you see here with the psychedelic colors, that's just an internal tool that we use to determine how many forms that we have. You might notice that the similar colored panels are similar in shape. So we'll make a form for the green panel, the pink one, the blue, the maroon, and the orange, and we'll pour as many as 5 panels the same day. And then we'll pour them, use those forms over and over again.
Yeah, this is a very good illustration of how the architect and the constructor are aligning on how that they're unifying on how it's built. So it helps save time and discussion where the team is more unified in how it gets produced.
Yep. So then we will go on to the initial shop drawing phase, and that will be a layout of the project that will include some details. All of the panelization is there, and then it will be returned to the design team for what is typically a customary 2 to 3 week review time. After that, we will get the submittal back, we the precaster, and it'll either be approved, rejected, or most commonly it will be approved as noted. They'll approve it, but there might be a few little comments here or there about what they want to do at a corner, or maybe they've got some recessed outlets or openings, and we'll capture those dimensions so we know what to pour. Here you can see the gym. This project consisted of a gym space and then an ancillary space next door, a little 2-story space. So if you took this space and you cut a section through it, this is what you'd have. You've got the gymnasium, then there's right next to it a fitness center and a wrestling room. And if we took that section and blew it up, that's what you'd have there to the left. That's our wall section. So looking at the details here, you can see the wall connection, and then also in the lower right corner, the foundation connection, and all 3 types of steel. You've got the structural steel, which goes into the structure, the cast in place foundation or footing. You've got the panel steel, which actually goes into the panel. And then you've got the loose steel, which is the loose pieces of steel that are shipped out to the job site loose, that might be part of that welding process to tie everything together. So everything that is related to the precast system is going to be provided by the precaster, including the steel that's going to be put in the footings and foundations. So the precast is providing a complete building system for you. There's different ways to do a load-bearing panel. In this case, they used a haunch. Now, once the shop drawings get approved, then we'll go into what is called piece tickets, and that is where we actually draw every individual piece that is being produced. And as you can see, there's obviously a lot of detail there, but this is what they will use on the production floor to actually build every individual piece. So they will do that. Obviously, our internal quality control will be there checking that process as it happens, and there'll be a post-pour check as well before it's sent out to the job site. And then at the end of the project, we will do a set of field use drawings, and that becomes a valuable resource for if there's ever going to be a renovation to the project. They might want to remove a panel, alter a panel, cut in a door, expand a window. We're never shy about, if it's a previous project, taking, phone calls, and our in-house structural engineers being part of that project process and working as advisors, when and if that happens. But the field use drawings ends up being a handy resource for everybody involved. So here, this is actually not Tekamah Herman, but I wanted to show a construction photo of a double T roof being installed, because that is obviously a very common method in these high wind shelters. Going back to Tekamah Herman here, in this case, that had a very long span, over 100 feet. So they went with a steel truss roof in that case. So here you see it under construction. Here you can see it completed. And here you can see the fitted rooms there, the 2-story space. And here you can see the completed project. There was a charcoal colored precast and a random blend thin brick. So what started out with, lines on a page is a fully completed project. So a lot of architects are like Batman. They ask us, does it come in black? And the answer to that question is We can do a charcoal. This is about as dark as you can get. This and the charcoal that you saw on James's project that he worked on, West Park Elementary. So we can't do a jet black, but we can get pretty dark with an integral color precast without any stain.
Yeah, and I'd say that's a good thing to know, of knowing the limits of what you can do successfully with the stain to maintain the matrix structural integrity without trying to push it too far. And through those small sample mock-up processes, it's very successful to have a good partner like Enterprise that will produce any number of sample mock-ups for you, right, Dirk?
Yeah. Touche. Well, we are accidentally right on time. So we've left 10 minutes here for questions. So I will let our moderator interject. Hope we got through talking before you got through listening.
Yeah, thanks, James and Dirk. Let's start answering some questions. There's quite a few questions in the chat pane here. Remember, if you want to, there's still time to submit questions if you want to submit. So let's get in, dig into some questions here for a few minutes. First question here talks about any rebar corrosion issues seen after acid etching. Have you seen any issues with acid etching a panel and corrosion of rebar reinforcement?
So I personally have not. I will tell you, when you're talking about acid etching, the word acid, it's a little jarring to people, but you know, we're talking about a 5 to 10% muriatic acid that is being sprayed in a controlled plant environment. If you were on site and it was a masonry project, they'd be using a 25% muriatic acid on site, just spraying it everywhere. And even that, you know, meets the EPA guidelines. So it's a pretty mild acid. And short answer is no, I have not seen that.
Yeah, I would say it's purely topical, like very surface level, where it's applied to the face out of the form to give that light etching crazing, but it's not penetrative, and it only is very, very skin deep. And as Dirk said, it's done in a controlled environment after they pour it in a fashion in the yard at the plant.
Next question here. Can you talk a little bit about reinforcement of these panels and how they're reinforced?
So there are two primary methods that are done. One is pre-stressing. One is mild reinforcing. Pre-stressing is, you know, pretty common in the industry. You have basically you know, a coiled strand that is pulled, you know, to 30 kips. It's released when the concrete reaches a certain designated strength, and it allows you to do longer spans. It reduces cracking. And there's a lot of benefits to pre-stressing. Interestingly enough, though, there are some times that call for mild reinforcing. We did a project in 2015 where terracotta was cast into precast, and it was really important to get, you know, 100% composite action on that project. And by that I mean that panel, insulated sandwich panel, needed to be acting as one panel. And in our R&D, we realized mild reinforcing was actually the way to go, and that's achieved just with wire mesh and rebar.
Okay. Next question here I've got is talks about built-in architectural finishes. Can you talk a little bit about anti-graffiti and how you know, what kind of recommendations you make to architects and contractors as it relates to graffiti on panels?
Sure. So there are anti-graffiti sealers that can be put on a panel. All things being equal, we actually recommend that our panels not be sealed because your precast already provides a moisture barrier, and it's not necessary. So what can happen is that sealer can wear unevenly over time, and you have an uneven sheen, and it, becomes a maintenance issue for the owner because they have to, reseal it every 15 years or so. However, if you're in an area where graffiti is a concern, or because of the nature of the client, or for whatever reason, they do have some sealers that work in that way, and it's typically a field applied method.
Yeah, I would add to that it's per preference of the client. And I think from what we've seen previously is that, yes, you do not put it in day one as part of integral to the casting of it. It's a post-applied sacrificial layer that is after the precast is up and pretty much I'm at the end of the job, that sacrificial layer is put on, and it is a one-use kind of protectant, especially on maybe not as much as like the thin brick applications. It can be there, but when you have more exposed matrix color aesthetics, that the graffiti will show up more. So that's where we're looking at applying it maybe within like the first 12 feet from the finish grade, and that sacrificial layer is then power washed away if it was abused and then reapplied. So it's being knowledgeable about how it is done, its life expectancy, and then the maintenance use from the client's perspective of what they're wanting to do, how they're looking to use products like that versus observational security methods like cameras, sensors, things like that. So it's an interesting thing, but it does exist.
Yeah. Okay. Next question here. I know precast is a delegated design, and this question kind of is inquiring as it relates to delegated design. Can you talk a little bit about what the precaster engineer designs versus what the building engineer designs? Kind of how that works in the precast world?
Sure. So you're going to have a structural engineer of record on the project, and you're going to have a specialty precast engineer. And that might be an in-house precast engineer, or it might be one of their trusted out-of-house resources. But those two are going to work together. Delegated design it's become pretty common these days, and the way it works in all practicality is, the structural engineer of record takes responsibility for, basically all the lateral loading, and the structure itself. The precaster actually takes responsibility for the precast connections, and they're providing a lot of information like, weight and things like that, just to ensure that the engineer of record is right sizing the footings and foundations and things like that.
Yeah, and I would say that a lot of it with that delegated design, there's clear language in architect specs and structural engineer specs of those swim lanes that need to be followed for how to properly bid it, and then follow the recommendations of the architect of record, structural engineer of record, for precasters to bid on it equally, and then be able to do their due diligence to provide the design that is shown in the drawings as expectations. So, and that's also working with your construction partner on those requirements as well.
Okay. Next question kind of relates to the heights of, especially, I guess, gymnasiums. Question about, what are these gym panels high enough to support, high school basketball, volleyball, whatever it might be inside these spaces?
Yeah, a short answer is yes. A really common height is in the low 30s. We usually start asking questions when you get into the 40s. But yeah, they can support volleyball, basketball, all kinds of sports.
Yeah, competition gyms, you have full competition gyms that are encased in precast, and it's almost where The roof structure itself is probably more of the questionable design object for the spans needed for those large athletic rooms versus the height of the exterior wall, which precast, yeah, like Dirk said, you can get pretty tall to satisfy that need. It's then the design of all the overhead equipment, especially how it's mounted to the roof superstructure and the coordination of the secondary equipment such as basketball goals, net, volleyball nets, etc., and how that's coordinated to help work with that span and relative height of the overall space supported by the precast.
Okay. I got one here kind of related to the graphic concrete you talked about in that Murphysboro project. Can you just talk a little bit about that? They were asking, is that available locally in the U.S. As far as the graphic concrete?
It is. Full disclosure, we actually buy just the membrane, the paper from Finland. So just the roll of paper is sent over from there. There are, and that's actually graphic concrete. There are a couple of competitors that do similar applications, and I believe some of those might be in the U.S.
Okay. Here's one about thin brick. Do you have a recommended or preferred panel width that best courses and takes panel joints into consideration as far as thin brick?
That's a fun question. So everything needs to course out, and incorporating corners is a whole thing. So I think starting with understanding your joints. Your precast joints are 3/4 to 1/2 inch, depending on it, and then sometimes the mold, the inlay mold joints for the thin brick are sometimes start on the edges with that precast joint. So you got to understand how the module of the precast works, and then going to another scale is how that brick courses. If you have half bricks on the side, my big pet peeve is not cutting bricks that don't look natural. Dirk knows that. Utilizing corner bricks, which I know Endicott and Endicott's a great manufacturer for it. Enterprise is a great constructor for it. So looking at overall, going back to masonry dimensions and understanding your brick module will then help you course it out. So, and that's all achievable with, 8s, 10s, things like that. And it's knowing when to incorporate a half brick or a more detailed design that works with your panels. Probably the word of warning is, then are you doing a consistent panel module, 10 feet, 8 feet, 12 feet, that is producible for your precaster, where then the detail of how your bricks course needs to be linked into that. So I think it's a bigger question, but ultimately you can start at a higher level of a clean dimension and then work down from there.
Yeah, and an important question to ask is if your brick manufacturer meets the recommended tolerances of PCI. If it meets that certification, and there's a few great companies that do that. I know we've dropped Endicott's name a few times, Summitville, Metro Brick. There's some others, but then there's also a number of companies out there that just slice full brick and they say, oh, it'll work. It's fine. We've done it before. We did it on this project that's been standing up for 2 years. That's where you have to be really careful, because different precasters might have different levels of risk tolerance, and whether they're, even willing to take on that experiment. So if you just work with brick companies that meet those recommended standards, you save everybody a lot of trouble at the end of the day. And you do have some good choices. They've got a nice color range. I've never had issues, with needing to match an existing building. So yeah, encourage you to unlock those resources. And I think there's going to be another webinar in July that's going to take a deep dive just on thin brick. So that'll be interesting to hear.
Okay. Well, we're out of time. So I want to say thanks again to James and Dirk. Appreciate your help today. And thank you to our participants for attending today's webinar. You'll receive an email with a link to your certificate of attendance within 10 business days. Thanks again for joining us and have a great day.
Thanks, everybody.